So on this last one, what we have to do is it tells us, first of all, that they're all going to be parabolas. We need to come up with the equation, and so we have to work backwards. Okay, and well, we don't have to come up with the equation. It just says find the graph. So if we have this as a graph and we know it's a parabola, what would we know? We know one x-intercept, right? Because there's one vertical asymptote, we know that there has to be an x-intercept there. Are there any points that you can tell what they're equal to? So can we look on our red graph, and are there any points that you can tell what they are, or at least estimate what they are? So we're looking at this one, and you're saying -1, 1 over 4. So where would that point have been on the original graph? -1, 4. Yeah, sometimes there's going to be ones that are really easy to tell. Okay? There's always a point that you can know for sure. You know that where the y value is equal to 1, what had to happen to have it equal to 1 before? You'd have to have 1 over 1. So that point's not going to change. So if we look on this graph, is there any place where the y value is equal to 1? If I go across from 1, it's here and here. So I know those points have to be there. But the rest, it would just be something where you're kind of eyeballing it, like we said, that looked like 1/4. Someone else might say it looks like 1/3. Depending on how you see that, you're going to get your parabola more or less this way. And that's how you draw the parabola based on the one that you had before. Same thing in this second one. What do we know for sure? Okay, we have 2 vertical asymptotes. What does that mean about our parabola? We have 2 x-intercepts, 1 here, 1 there. This one's nice because it has a point labeled. What's going to happen to 0, 1 over 2? Where would that have been on our original graph? 0, 2. And once you have that, you have enough information to graph it. If you wanted to be even more accurate, what did I say about y equals 1? Those points aren't going to change. So if I look on my original graph, do I have any points where y is equal to 1? Right there and right there. What other point is not going to change? What other y value makes it not change? Because 1 doesn't change, because if you do 1 over 1, you still have 1. Or is that the only one? Are there any other points that don't change when you do 1 over? 1 over 0 is not allowed. No other points? Only those 2? So if I draw my parabola, this will be the only place that it intersects the other graph. Some people are saying, no, it hit it again. Where did it hit it again? At -1. Now, if you imagine -1, what happens if you do 1 over -1? It still stays -1. So if we look at where y is -1, here and here, it's going to go through the graph there again. So if we wanted to be really accurate, our parabola goes through all of those points. And this one, we actually have a lot of information. We could write the equation of this graph quite easily. What's our vertex of the blue graph? 0, 2. So which way is it opening, up or down? Down. It goes over 1, down 2 to start with. So we're going to have -2 x squared, because of the 0, plus 2. That would be the equation of our blue graph. So questions you can do for this one. Number 9.